Find the number of solid spheres, each of diameter 6 cm, that can be made by melting a solid metal cylinder of height 45 cm and diameter 4 cm. Solution. Given diameter of solid sphere is equal to 6 cm, diameter of cylinder is equal to 4 cm, height of cylinder is equal to h is equal to 45 cm, radius of sphere is equal to r1 is equal to 6 by 2 is equal to 3 cm, radius of cylinder is equal to r2 is equal to 4 by 2 is equal to 2 cm. Let n be the number of spheres. N into volume of one sphere is equal to volume of cylinder. N into 4 by 3 pi r1 cube is equal to pi r2 square h. So here putting the values, n into 4 by 3 into 22 by 7 into 3 into 3 into 3 is equal to 22 by 7 into 2 into 2 into 45. So n into 9 is equal to 45. Therefore n is equal to 45 by 9. Therefore n is equal to 5. A canal is 300 cm wide and 120 cm deep. The water in the canal is flowing at a speed of 20 km per hour. How much area will it irrigate in 20 minutes if 8 cm of standing water is desired? Solution. The volume of water flows in the canal in 1 hour is equal to width of the canal into depth of the canal into speed of the canal water is equal to 3 into 1.2 into 20 into 1000 meter cube is equal to 72,000 meter cube. In 20 minutes, the volume of water is equal to 72,000 into 20 divided by 60 is equal to 24,000 meter cube. Area irrigated in 20 minutes, if 8 centimeter, that is 0.08 meter standing water is required, which is equal to 24,000 divided by 0.08, which is equal to 3 lakhs meter square is equal to 30 hectares. Two cones have their heights in the ratio 1:3 and radii in the ratio 3:1. What is the ratio of their volumes? Solution. Given ratio of heights of two cones is equal to 1:3. Ratio of radii is equal to 3:1. Let h and 3h be the height of two cones. Also 3r and r be the corresponding radii of cones. Ratio of volumes is equal to 1 by 3 pi r1 square h divided by 1 by 3 pi r2 square h2. So r1 is equal to 3r, h1 is equal to h, r2 is equal to r, h2 is equal to 3h. Now substituting the values, which is equal to 3r whole square into h divided by r square into 3h, that is equal to 9r square h divided by 3r square h. Here r square h and r square h are cancelled, so remaining 3 by 1. Hence the ratio of volumes is equal to 3:1. It is so easy, isn't it? A cubical ice cream brick of edge 22 cm is to be distributed among some children by filling ice cream cones of radius 2 cm and height 7 cm up to its brim. How many children will get the ice cream cones? Solution. Let n be the number of ice cream cones. Volume of cubical ice cream brick is equal to 22 cm into 22 cm into 22 cm. Radius of cone is equal to r is equal to 2 cm. Height of cone is equal to h is equal to 7 cm. Volume of cone is equal to 1 by 3 pi r square h is equal to 1 by 3 into 22 by 7 into 2 into 2 into 7. N into volume of cone is equal to volume of cubical ice cream brick. So n into 1 by 3 into 22 by 7 into 2 into 2 into 7. is equal to 22 into 22 into 22. Simplifying further, we get n into 1 by 3 into 4 is equal to 22 into 22. N is equal to 22 into 22 into 3 divided by 4. So n is equal to 363. Therefore, 363 children will get the ice cream cones. 3 cubes of a metal whose edges are in the ratio 3:4:5 are melted and converted into a single cube whose diagonal is 12 square root of 3 centimeter. Find the edges of the 3 cubes. Solution. Let the edges of 3 cubes be 3x, 4x and 5x respectively. Volume of the cubes after melting is 3x whole cube plus 4x whole cube plus 5x whole cube, which is equal to 216x cube centimeter cube. Let A be the side of a new cube so formed after melting. Therefore, A cube is equal to 216x cube. So, A is equal to 6x. Given diagonal of single cube is equal to 12 square root of 3 centimeter. That is square root of a square plus a square plus a square is equal to 12 square root of 3. So, a square root of 3 is equal to 12 square root of 3. Therefore, a is equal to 12. Thus, 12 is equal to 6x. So, x is equal to 2. Now, substituting the x value. Now, 3x is equal to 3 into 2 is equal to 6. 4x is equal to 4 into 2 is equal to 8. 5x is equal to 5 into 2 is equal to 10. Therefore, the edges of the 3 cubes are 6 cm, 8 cm and 10 cm respectively. Rashid got a playing top as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone, surmounted by a hemisphere. The entire top is 5 cm in height and the diameter of the top is 3.5 cm. Find the area he has to color. Take 5 is equal to 22 by 7. Solution. Total surface area of the toy is equal to curved surface area of the hemisphere plus CSA of cone. Curved surface area of the hemisphere is equal to 1 by 2 into 4 pi r square is equal to 2 pi r square, which is equal to 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2, which is equal to 19.25 centimeter square. Height of the cone is equal to height of the top minus radius of the hemispherical part is equal to 5 minus 3.5 by 2 centimeter is equal to 3.25 centimeter. Slant height of the cone L is equal to square root of r square plus h square. Square root of 3.5 by 2 whole square plus 3.25 whole square is equal to 3.7 centimeter approximately. Therefore, CSA of cone is equal to pi RL, which is equal to 22 by 7 into 3.5 by 2 into 3.7 is equal to 20.35 centimeter square. Hence, the surface area of the top is equal to TSA of the toy is equal to CSA of hemisphere plus CSA of cone, which is equal to 19.25 centimeter square plus 20.35 centimeter square, which is equal to 39.6 centimeter square approximately. A cone of height 24 centimeter and radius of base 6 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Solution. The volume of cone is equal to 1 by 3 into pi r square h. Here r is equal to 6 centimeter and height h is equal to 24 centimeter. Now substituting the values, which is equal to 1 by 3 into pi into 6 into 6 into 24 centimeter cube. If r is the radius of the sphere, then its volume is 4 by 3 pi r cube. Since the volume of clay in the form of the cone and the sphere remains the same, we have 4 by 3 into pi r cube is equal to 1 by 3 into pi into 6 into 24 centimeter cube. So r cube is equal to 3 into 3 into 24 is equal to 3 raised to 3 into 2 raised to 3. So r is equal to 3 into 2, which is equal to 6. Therefore, the radius of sphere is 6 centimeter. Metallic spheres of radii 6 centimeter, 8 centimeter and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Solution. For sphere 1, radius r1 is equal to 6 centimeter. Therefore, volume V1 is equal to 4 by 3 into pi into r1 cube. For sphere 2, radius r2 is equal to 8 centimeter. Therefore, volume V2 is equal to 4 by 3 into pi into r2 cube. For sphere 3, radius r3 is equal to 10 centimeter. Therefore, volume V3 is equal to 4 by 3 into pi into r3 cube. Also, let the radius of the resulting sphere be r. Now, volume of resulting sphere is equal to V1 plus V2 plus V3. 4 by 3 into pi into r cube is equal to 4 by 3 into pi into r1 cube plus 4 by 3 into pi into r2 cube plus 4 by 3 into pi into r3 cube. 4 by 3 into pi into r cube is equal to 4 by 3 into pi into r1 cube plus r2 cube plus r3 cube. Now substituting the values of r1, r2 and r3 we get, and cancelling the term 4 by 3 into pi on both sides. R cube is equal to 6 cube plus 8 cube plus 10 cube. R cube is equal to 1728. So R is equal to 12 centimeter. A spherical glass vessel has a cylindrical neck 8 centimeter long, 2 centimeter in diameter. The diameter of the spherical part is 8.5 centimeter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Check whether she is correct, taking the above as the inside measurements and pi is equal to 3.14. Solution. Given for the cylinder part, height h is equal to 8 centimeter and radius r is equal to 2 by 2 centimeter is equal to 1 centimeter. For the spherical part, radius r is equal to 8.5 by 2 is equal to 4.25 centimeter. Now, the volume of this vessel is equal to volume of cylinder plus volume of a sphere is equal to pi into 1 whole square into 8 plus 4 by 3 into pi into 4.25 whole cube, which is equal to 25.12 plus 321.6, that is equal to 346.67 centimeter cube. A tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also, find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered with canvas. Solution. It is known that a tent is a combination of a cone and a cylinder, as shown below. From the question, we know that the diameter is equal to d is equal to 4 meter, L is equal to 2.8 meter, slant height. The radius of cylinder is equal to the radius of the cone, so r is equal to 4 by 2 is equal to 2 meter. Also, we know the height of the cylinder h is 2.1 meter. So, the required surface area of the given tent is equal to surface area of the cone plus surface area of the cylinder. is equal to pi RL plus 2 pi RH, which is equal to pi R is common into L plus 2H. Now substituting the values and solving it, we get pi R into L plus 2H is equal to 22 by 7 into 2 into 2.8 plus 2 into 2.1, which is equal to 44 meter square. Therefore, the cost of the canvas at the rate of rupees 500 per meter square for the tent will be surface area into cost per meter square, which is equal to 44 into 500. So, rupees 22,000 will be the total cost of the canvas. A solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of the cone is 2 cm and the diameter of the base is 4 cm. Determine the volume of the toy. If a right circular cylinder circumscribes the toy, find the difference between the volumes of the cylinder and the toy. Take pi is equal to 3.14. Solution. Let BPC be the hemisphere and ABC be the cone standing on the base of the hemisphere as shown in the figure. The radius BO of the hemisphere as well as of the cone is equal to 1 by 2 into 4 cm is equal to 2 cm. So, volume of the toy is equal to 2 by 3 pi r cube plus 1 by 3 pi r square h, that is equal to 2 by 3 into 3.14 into 2 cube plus 1 by 3 into 3.14 into 2 square into 2, that is equal to 25.12 centimeter cube. Now let the right circular cylinder EFGH circumscribe the given solid. The radius of the base of the right circular cylinder is equal to HP is equal to BO is equal to 2 cm and its height is EH is equal to AO plus OP is equal to 2 plus 2 cm is equal to 4 cm. So, the volume required is equal to volume of the right circular cylinder minus the volume of the toy, which is equal to 3.14 into 2 square into 4 minus 25.12 centimeter cube, which is equal to 50.24 minus 25.12 centimeter cube, which is equal to 25.12 centimeter cube. Hence, the required difference between the two volumes is equal to 25.12 centimeter cube. A little progress each day adds up to big results. Thanks for watching.